I think we're going to go ahead and get started. So thank you so much, everyone who joined us for another VES-Artex Academy webinar. Today we are joined by Dr. Mario Mondaca. He's going to be speaking on how your barn is not that special, and that's okay. Before Dr. Mondaca dives into this topic, just one quick housekeeping item. You can ask questions throughout the presentation by typing them into the Q&A box, which is at the bottom of your screen. However, we will address all the questions at the end of the presentation. So with that, Dr. Mondaca, the floor is yours.
Thank you, Annie. Thank you very much, everyone, for joining. My name is Dr. Mario Mondaca. I'm an engineering specialist or technical expert at VES-Artex, specializing in ventilation design, facility design, and all of that. There we go. Sorry, I was having an issue with my keyboard. I have a biosystems engineering degree, basically throughout my whole career, focusing in different areas of agriculture, hydrology, hydraulics, environmental engineering, and my PhD was mainly in dairy ventilation. And I did a postdoctoral study at the Dairyland Initiative, where I more or less learned the basis of facility design. And my role was really to develop a ventilation assessment methodology and formalize the recommendations. If you're not familiar with dairy ventilation, there's a lot of different recommendations. Sometimes they conflict with each other, and there wasn't a very clear path of what makes good ventilation design. So my role was to more or less formalize that, and that culminated in a chapter recommending the different performance indicators for a ventilation system. I joined Artex Barn Solutions roughly 3 years ago as a contractor, doing mostly CFD analysis and design analysis. And when Artex and VES merged, I was taken up as full-time, helping with the CFD and sales supports, but also with technical expert on research topics, as well as our configure price quote tool, which we will see today in this presentation. So my role, I mostly do a lot of sales support with CFD, looking at some of these more complex barn designs and what their flow will look like. In the top right, we have it's a completely neutral pressure barn, having fans provide the air coming in, distributed at different areas. This is a particularly wide tunnel barn, so that's why it needs the extra fresh air injection. And then the bottom right is a barn with center exhaust, so fans aiming towards the center and exhausting in the middle of the barn. So that's what I do for the more challenging problem, but on a more day-to-day, and I work into helping design the more standard barn designs. Something that I did at my tenure at the Dairyland is that I developed and designed their adult cow ventilation spreadsheet, which calculates volume and the three main design numbers for ventilation automatically. And the reason we came up with this spreadsheet, like I mentioned before, there were a lot of different variations on ventilation designs and the way the numbers were described. So the goal was to streamline ventilation design in something that is simple enough that the average, producer or dealer can work with without having to know everything there is to know about ventilation design and fan performance, and give them a good idea of what their ventilation system should look like. It won't be the perfect design, right? But at least you'll know roughly how many fans you need and what kind of operating costs you should be expecting. And I've continued that VES-Artex, looking at ways to improve and standardize ventilation design further. I mentioned that we'll be using the CPQ tool, or viewing the CPQ tool, and what that is, if you're not familiar, a CPQ process or configure price quote is just a way to streamline the sales process. You're probably most familiar with if you ever bought a Dell computer or an iPhone, you go to a website and they give you some specific options that you can pick. And based on those options, they automatically give you a price. and lead times without having to talk to a salesman. So you can more or less set up your order and your whole computer without ever having to talking to anyone, and it comes to your house, and it's all streamlined and pretty easy to do. And if you need something more custom, you can always contact them and go that route, right? So the idea is to essentially do that with dairy ventilation, finding a way to create these configurations and have as little back and forth as possible. But it's a very challenging problem because, unlike the title says, a lot of dairy barns, or at least the industry considers all dairy barns to be special. So that's kind of where I fall into this equation. Why is a PhD in CFD designing what is essentially a sales tool, right? So, well, there's a lot of facility design that goes into this that shapes the barn, ensuring cow welfare through facility design, through stall design, through transfer lane design. All of that generates space, dimensions, and that space has to be ventilated. Since we have to streamline that, you need to understand both sides of ventilation and facility design. But I also see it as a pretty good research tool. Once this is ready, in theory, we will also generate a database of barn design compared to ventilation design. So I think there's a lot of value in standardizing this, which is why I kind of delve very deep into this analysis, while making sure, of course, that we're meeting the typical ventilation recommendations that you'd see on a ventilation design. So how do we tackle this very challenging problem of standardizing ventilation design and facility design on such a special dairy barns? Well, by assuming the opposite, that your barn is not that special. That's a rather aggressive title, but it's because if they're not that special, then we can standardize them. And I more or less had to brainwash myself to believe this in order to tackle this challenge. And now that I think we got it to a point where it's ready to be shown, it's my job to brainwash you and show you that we can look at dairy barns in a different way. They're still special. There's no pair like there's no two barns that are exactly the same. But just like snowflakes, there's no two snowflakes that are the same. They all follow a very specific set of categories and identifiers that can help us study and understand them. So that's what I basically did. I took everything I know about barn design and created these very high-level categories to explain what a dairy barn is in simpler terms. So I'm going to walk you through a little bit of that. I'm not going to go too deep because otherwise we'd be here all day. But let's look at dairy barn anatomy. I'm going to focus on freestyle barns, mostly because they're the more, well, recently the more common ones that are being designed, at least in the area that we operate. So there's bedded pack and tie style, but for now, let's focus on the anatomy of a freestyle barn. And after much reviewing of a lot of plans that I've looked at personally and I was shared by sales, I came up with two areas: the animal occupied zones, or where you have the pens, and the shared zones, or the lanes, where you have transfer lanes, feed lanes, drover lanes, and so on. Inside of the animal occupied zone, you have different types of pens, feed alleys, stall banks, each of those having their own design requirements. So how can I describe all of that as simple as possible? And I came up with these 4 identifiers. So we have a pen type, whether you have a 3-row pen, a head-to-head pen, or a single-row pen, shown here on the right. Whether your barn, the first lane by the sidewall, is it a lane or a pen? Where your transfer lane is, it's because it can be in an H configuration, splitting the barn in half, or it can be on the edge of the barn, as you're seeing in some of the larger facilities nowadays. And the biggest difference, I think, from the traditional description of dairy barns is the number of widthwise pens. This is something I came up, the way you would typically define a barn, for example, this barn shown here, this would be a, depending if you're a bed or a builder would probably say a 2-row head-to-head because there's 2 rows of stalls. A veterinarian will probably say it's a 4-row head-to-head because there's 4 rows of cows, right? So or at least the software, considers this a 2-pen barn, at least widthwise. You could have more pens along the length. And inside of those pens, they're head-to-head pens. So 2 head-to-head widthwise pens. We then took this idea and really kind of went through as many possible configurations as possible. What does it mean for the end wall? What changes when you have an edge configuration versus a transfer line at the edge, and so on and so forth? How does the end wall is affected by the garage doors? Looking at as many barns as we could, compared it to as many quotes that we've done as we had available with the full barn information, and started to quantify that into numbers and develop these abstract mathematical correlations between these 4 inputs and the barn layout. For example, if you have a 3-row barn that starts with a pen by the sidewall, then your total number of single rows will be 2 minus the number of widthwise pen modulus 2. That's just fancy programmer talk to, if it's odd, there's going to be 2 single rows, and if it's even, if it's even, there's going to be 2 single rows. If it's odd, there's going to be 1. Because every time you have a pair of single rows together, you typically combine them into head-to-head. So everything in the barn has these abstract mathematical correlations. And once we got to a good point, we put all of this, well, I put all of this into an Excel prototype. So given barn dimensions and these 4 inputs, we can automatically generate 2D barn layouts pretty close to what they are in the field. Of course, not perfectly identical, but pretty close to what we're seeing. And we have to make a lot of the assumptions of the dimensions of alley widths and all that, but they tend to follow pretty standard ranges, right? So a feed alley typically is between 12 and 14, depending on the producer. And because we have those abstract correlations, you can see it on the left when we switch to the drawing. There's this, it knows what each of these sections are. So it knows that it's a crossover, it knows that it's a stall, it knows that it's a lane. So not only are we drawing the 2D layout, we also know what each of these sections are, so we can do analysis and other stuffs on them that we'll show a little bit later. But I still remember when I presented this prototype, I think November of last year. And we've always had this goal of the CPQ and streamlining the sales process, but it was a very challenging idea. And I think once they saw this prototype, it was kind of the turning point. I think within 10 minutes after the presentation, our CFO called me and said, you need to work with the CPQ team because this is how we're going to be able to help producers and get things going. So we worked on getting that on the web tool, and this is what it looks like. Same 4 inputs. All the alley dimensions and all of that have been simplified and are defaults. But this more or less lets a dealer or a sales have a very meaningful discussion with the producer real time on the farms. Like, well, what if we did a tunnel? What if we did this many rows and look into barn design while looking at ventilation, which is one of the biggest gaps we've had in ventilation design. Usually ventilation design is after the building has been discussed. So with this, at least for a new facility, there's the opportunity to now have at this high level discussion of layout and ventilation at the same time. And finally, once they go through the whole CPQ process, we can also show, in this case, this is a tunnel barn flowing from right to left. We're showing the curtain inlets. This would be a partial positive system, so there's positive pressure fans. Since we know what's a stall, what's a crossover, we can lay the circulation fans over the stalls. Not only that, the way it's calculated, we know the length of this bank, so we can check the bank length and make sure the fan spacing is proper and make sure they're always starting at the crossover, and do these more advanced sort of layout things that typically you would have to wait 1 or 2 weeks to understand. But we're still assuming it's symmetrical and all these things, and that's not the reality, right? A dairy barn is special because it's usually not symmetrical. There's always variations, particularly in the larger facilities. Um, Sometimes you'll have multiple age groups or multiple producing groups. They'll have slightly different stall dimensions. There might be office buildings that the drawing doesn't show, or some special needs pen, a maternity pen, etc. But it's pretty close. So here's 2D barn of an automatic milking system layout. It's a 3-row pen. There's 5 widthwise pens in my way of saying it. So it'd be, we can get basically the same layout, except we can't, at least right now, we can't do AMS units. We can't do variable crossover size yet. So usually outside of the AMS unit, you'll have this larger crossover kind of acting as a semi holding area, or as they exit to have a place to cool. The ridge is actually not in the center here. I think this was an addition. So whereas in the tool, it's going to assume it's in the center. And then there's these outside lanes for driving that are not included in the default tool. So subtle differences that make, the kind of blunt layout compared to the actual barn. But those subtle differences actually have very little effect on at least for ventilation in terms of cost. So it will change the specifics of the design and the final number of fans, but in the grand scheme of things, we're only 10 to 20% off what the actual quote is. So that's very important information for the producer to have kind of immediately. Sometimes some of these decisions, we're talking order of magnitudes, right? How much am I going to spending on this system? And is it within my budget? And if so, then we can start looking deeper into the design, as opposed to having to wait 1 or 2 weeks to get back an answer with a quote. So being able to have these discussions on farm about the design and how the design is changing, I think is very important. And we've seen a lot less difference between quotes that we have finalized and what the tool comes up when looking at a new facility, because often new facility designs don't have those custom changes, at least not a lot of them, that happen as the building is going up. So the difference tends to be a lot lower then. So I'd like to go through, kind of show you what this ventilation design process looks like. To do that, we'll do a very quick review of ventilation design, just so when I'm throwing slang at you, you know what I'm talking about. So we have our key performance indicators. You want air exchange rate of typically 4 air exchanges in the winter and somewhere between 40 and 60 in the summer. Minimum cooling airspeed of 200 feet per minute everywhere. We recommend at least 400 feet per minute, ideally, and in very hot areas, 500 to 600 feet per minute. And ensuring that the system works throughout all seasons with the inlet design and having a good transition methodology between winter and summer. And for mechanical systems, you'll hear me say tunnel ventilation, cross ventilation, or low profile and hybrids. Tunnel is where the air cross parallel to the feed lane. Shown here, cross is when it flows perpendicular to the feed lane. And then hybrid is typically a natural barn that combines some of the effects of the natural and mechanical. The most recent commonly one being the all-season hybrid, or commonly known as a Gordy barn, if you're familiar. But I asked Courtney Hallback to let me show one of the examples they use on their adult cow ventilation workshop that actually happened last week. It's a mechanically ventilated 8-row barn head to head. I'm not going to show the answer, but we'll go through the design process. So this holds 800 cows. It has 5 crossovers, 490 by, so, and here's the dimensions. So let's quickly show what that looks like in the configurator. Make sure I'm hiding out the prices. So here's our configurator tool. We're gonna build this custom barn. It's a cross ventilated barn. We default to negative pressure. Probably steel. I think it was 490 by 490 by 224 with 15-foot sidewall and a peak of 20. These are just options to help filter out fans in terms of voltage, how many cows are in the barn, and the stocking density. It was it had 4 pens starting with a feed lane, and the transfer lane was on the edge. So with 5, as you can see, the 5 crossovers got automatically calculated based on the typical recommended distance of stalls between the crossovers. And here's our catalog of fans, so we can just pick. And I think I forgot to define the baffle of 8 feet. We can adjust the fence, get the airspeed that we want. We're not going to be using a power baffle, and then do our curtain. Then it's going to go through all the calculations. The summary page looks like this, where you have all your dimensions, KPIs, but we also calculate the controllers that you will need for staging, the curtains, and show it all here for the producer and for the dealer, so that you can have these discussions, and at any point you can go back and edit the design. So let's go back to the PowerPoint. So thanks to this, we have now, at least at the beginning for new facilities, for sure, we have a new standard way to set up this ventilation system, very similar to what I've done before at the Dairyland, but now it includes some of these controllers and curtains and a more complete system that we had before. But now that it's standard, we can kind of go very deep into the possibilities. And one of the main concerns was that, for example, to use the spreadsheet from the Dairyland Initiative, you go to a training session that's at least 1 day long. So it's not intuitive to make all of these designs, even with these tools that have streamlined the process. So I worked on something I call the single input design. Right now we have, we went through at least maybe 40 different inputs, including fans, dimensions, voltage, etc. And we have this method we developed this method of creating a barn layout from these 4 inputs. So what if we try and simplify it further? So at the Dairyland Initiative, I was very thankful, very lucky. Dr. Nigel Cook more or less showed me how you go through designing a dairy facility. I think they have a workshop on that, and I would highly recommend it. There's 3 main limitations for a dairy herd: manure handling, food availability, either through cropland or prices, and your parlor. So let's assume we have enough of the first 2, and we're only limited by the parlor because there's only so many hours of the day, right? So you can only milk so many cows, and you have to milk cows every day. So the idea is, well, I can use this parlor size to design a group size based on the standard number of parlor turns. Now that I have a group size, I can design a pen. Now that I have a pen, I can design, if I fill the parlor to completion, I can design a barn. And I have a tool already that creates the layout based on the barn inputs. And if I can create a layout, I can create dimensions and I can create a ventilation system. So the way it works is that it uses the parlor size or the herd size to calculate a complete barn and its ventilation system and its controllers and curtains. So the way you would do it to design this barn, you'd go through the parlor size, depending on the number of times you're milking per day, and the parlor turns, you'd find a group size. Based on the group size, you calculate your pen and so on and so forth, making assumptions along the way, right? So what if we make those assumptions for you and make all these calculations for you? Well, we could, in theory, give you a ventilation system design based only on one number. Let me give you a very simplified example. A common recommended value is 1500 CFM per cow. So if you know you need 500 cow ventilation system, well, 500 times 1500 is the total CFM that you need divided by the fan CFM, and you now estimated your ventilation system based on one number, right? But it knows nothing about the facility, it knows nothing about the airspeed, the air changes, anything like that. Whereas here is doing all of those, all the ventilation KPIs and the airspeeds, and we know where the stalls are, so we can do the fans and everything that is related to that. So when we run the single input, right now I default to a 4-row tunnel barn, but we could very easily default to a cross or a different layout. So so when you ask for the single input, you get this barn automatically, and then because we can switch back and forth, we can very quickly just change it. And if it behaves, I can show you what that looks like. So same tool where you would go and do the custom barn, but we use this single input design, and it just needs to know the parlor capacity or the milking herd size. What we just saw was an 800 cow barn. So we put 800 and then off it goes. So 497, 204, pretty similar, not exactly the same, of course, and it's split down the middle using a partial system. So let's change that to a negative system. And yes, and let's change the layout to a etch pen so it looks closer to what we had on that example, and update that. There you go, 5 crossovers. The barn layout more or less the same. Couple differences on the dimensions. The error changes are a bit high compared to the example, but we can very quickly edit that so it's closer to what we had, and we more or less get the same barn. We default to a bit higher error change on the single input, just because we want to overquote, and as people kind of edit, they should get a cheaper option. But the idea is, you know, here's all the circulation fans that you need, the curtain that you need, your exhaust fans, all from one, just from the number of cows. And it has proven to be pretty close in the ranges of roughly 300 to 800 cow facilities. When it gets really small, it tends to overestimate by like 20 to 30%. Mostly because we default to some very expensive options for that size of a dairy. Like they don't need a double top and bottom powered curtain, right? But that's just what we default on the tool. But between 3 to 800, which is a lot of facilities are that size, we're pretty close. I think some of the comparisons we've done have been somewhere within 20% overestimating. And a lot of that comes from the fact that our final quotes use BFD staging, which typically reduces the number of fans. So right now it's overestimating a little bit, but we're working to getting into that level. So a very standard and very quick estimate, very good kind of ballpark number of how much would a 700 cow barn cost me to ventilate. And that gives you a quote with the controllers, the curtains, everything you need. And it's a good way to say, oh, roughly this much, but would be happy to go through and get an actual custom design. It's going to help us reduce the quoting and decision-making time and be able to give meaningful answers faster and provide more access to some of these estimates while following proper ventilation design principles, as well as providing different users to be able to design ventilation systems, right? So anyone can run the single input and get a system. It may not represent the true barn that they're going for, but it is a ventilation system that follows all the recommendations. We also have a way to do templates. So 500 cow barn. And then once you get that to the summary page, you can go back to any part of the design and edit it. So it's really a way to give you a very quick answer. And if you really want to, you can go to and kind of hammer out the finer details. But why am I doing all of this? Well, I think it's there's a lot of power to having this kind of standardized designs and research. When I first joined VES-Artex full-time, I wanted to do a project to kind of do a statistical analysis of ventilation design, right? Like now that I have all this data, but what I quickly found is there isn't the veracity needed for academic research from our from that data, and I don't think there's anywhere that kind of veracity. So this will give us that, because now in theory, anytime there's a quote, it's accompanied by all the barn dimensions, all the fan, all the staging information, and if that system also installs, for example, dairy bus, we can collect its temperature performance data. And if the producer is willing to work with us, we can even get the dairy comp and start getting these more research statistical models that incorporate the full details of ventilation design. Whereas a lot of the current publications on ventilation and airspeeds say things like it has fans, right? We used fans of this size, but there's no information about the airspeed, the overall air change. Only recently the University of Wisconsin did a study on the airspeed, the FED. So it's an area of research that really needs to grow, and I think this is the kind of tools that can help us to get there by creating these very broad categories that can help us define dairy barns. And of course, as we do more of these quotes, we'll be able to compare the design and make meaningful design changes on the tool. Currently, we're working on staging and local temperature analysis to do ROI calculations, because the tool needs to be able to, show that the ventilation system will end up saving money. But one interesting problem we found is that dealers and salesmen really like the drawing part, right? So they want more features there. They want to be able to change specific parts of the pen to a different type, to change some part of the pen to a pack barn, maybe add a maternity area, things like that, so that it matches the producer's barn even more, because they're finding that producers really like having these discussions. They really appreciate being able to look at the layout and look, well, what if this was a tunnel? What if this was a cross? What's the price difference? Can we make it cheaper? Can we address some specific issues, right? And so they want more of the specifics there, and as well as automatically generate 3D barns. We're halfway there. I got the sidewalls up. The ridge is creating some issues, but that all sounds fancy, but oftentimes the errors in the CPQ with a real quote is that we had to cut 20% of the 72-inch fans for a smaller fan because there wasn't space on the end wall, right? So right now we don't know what the end wall looks like, but if we develop this 3D barn drawing, we would. So, and it would help us have a more accurate code and a more meaningful discussion with the producer that matches what his conditions is. So we're working on those improvements, as well as different facility options. Now we have very well-defined stall banks or stall islands. And then, so in theory, that means, well, we can design a stall system. We can design the sprinklers, the headlocks. We actually have already a feed front configurator in its alpha testing, and we're working on some of the style configurations as well. So, but all of this, like I said, being, I think an example in the style is one of our sort of installation gurus send us an Excel file with 22 different potential cases for style configuration. So we took that and we processed it through the same process as the barn, and we were able to create an equation that simplifies it to essentially an equation with, I think, 3 inputs. So creating these higher level definitions of a dairy barn is really helping, well, one, automate the process, but also it's going to help define dairy barns in a way that we can compare them more meaningfully. You know, a tunnel and a cross are actually very similar, at least in these big decision numbers of number of widthwise pens and so on. So I think we're going to learn a lot from looking at barns into this higher level of design and being able to quickly describe them with these very general definitions that give us actually a lot of information about the facility. It's a very rapidly developing tool. I think the way it looks 6 months ago and the way it looks now is almost like night and day. So if you'd like to keep up with the development, we will be presenting on the latest updates on this on World Dairy Expo this year. So I look forward to seeing you all there. And thank you very much for your time. And I'd be happy to answer any questions.
Perfect. Thank you so much, Dr. Mondaca. That was a really great presentation. We do have a couple of questions that have came through. So by using a tool like this, do you think we can build near perfect barns in the future?
It'll depend what you mean by perfect barn. If it's 100% symmetrical and follows the rules that I wrote, then yes, right? But I think we can start something I'm very interested in researching, and I've seen a couple of universities started delving into that area, is having a very well understood correlation between facility design and physiological responses. So from the industry side, I think it's our job to provide the university with these definitions and these descriptions so that when they do the research on the physiology, they can make these comparisons and potentially get to, like you said, a perfect barn design. But I've always been of the philosophy that there's no perfect sauce, only perfect sauces. So we're gonna find a variety of designs that work really well, rather than one design that works for every single situation.
Perfect. And will a service like this be available maybe for some of the smaller herds, or how can you utilize a tool like this for herds that maybe aren't quite as large?
It comes down to the assumptions we're already discussing. We for example, we default to 4 widthwise pens, mostly because, like I said, that's the space that we typically operate, 3 to 800 cows. But we could easily change that to default to 2 widthwise pens, right? In that condition, if less than 200 cows do this kind of layout. But the tool itself can do small herds. You just a single input needs to be adjusted afterwards. So this is something that we'd like to essentially have all of our salespeople using for every herd. Ideally, every code that comes through will have the design information run through this. So that we generate that database of facility design and be able to make these meaningful decisions in the future.
What is the biggest benefit to producers to utilize a configuration tool or have a barn that was designed by a CPQ?
This is a bit of a, I guess, a personal take, but because I've seen some of these design discussions for ventilation systems, and they tend to happen after the barn is laid out. Of course, not all of them, but I think if this tool can help shift that ventilation design discussion further up the chain to where the building isn't decided on yet and help shape the building, I think that's would be one of the strongest points, as well as giving them faster answers that are within design parameters. Because the ventilation system is in the grand scheme of things in a dairy facility, it's a very cheap part of dairying, right? Like the crop and the manure is very expensive in comparison, but it can have such a negative effect when done incorrectly. So if the barn is already designed in a way that makes ventilating challenging, it's a disservice to the producer, right? So ideally, having a way to do a very simple, high-level discussion of the ventilation system while designing the facility, I think that's going to bring a lot of value so that we're more in line with builders and the design process.
So how does a barn that's been designed from a configurator tool help those that maybe are a little more outside of the ventilation interest? So maybe nutritionists or vets.
That's a good question. I think bit hard to answer. I don't want to speak for them, right? But in general, just having a layout to discuss things can be very useful. Sometimes some of these discussions happen, just with nothing on hand. There's not always a drawing available. So if for example, if a nutritionist goes on farm and there's no drawing and wants to discuss group A or pen 8 or whatever, and instead of drawing it and sketching it on a notebook, they can just put it into this and get a 2D layout and talk about it that way. But I don't want to speak too much because that's not my area as to how this could be used by them, but that's how I would imagine. Having a 2D reference point is always very helpful.
What are some barn design parameters you see as becoming standard in the future?
Standard. You'd have to excuse me. I'm thinking standard in like the very strong like ASHRAE kind of standard. So I think you mean the more general, like commonly used. So not sure, honestly. I think we're starting to see some challenges in what I used to think was the standard, right? If you go beyond, at least my publication on cost, it says that once you go to 2,000 cow facilities, a cross-ventilated barn tends to be a cheaper solution, but we're starting to see some wide tunnel barn designs that are working really well as some of the bigger AMS units. So I think what we might see instead of standard barn is more like standard design philosophies. But that one's a bit of a tough to estimate.
All right. Well, I also have another tough question that just came in. So in an oceanic climate, in an old conventional 3/12 roof slope barn, that's a 4-row head-to-head barn that's 100 feet by 400 feet. Do I add overhead fans or air exchange fans if I only have a budget for 800,000 CFM?
I've tempted to just pull out the configurator. I would always ventilate first and cool second. But yeah, I think make sure you meet the air change KPIs, the making sure you have fresh air, because cows naturally cool. So if you're helping it exhaust their heat, that's going to help them. Whereas if you only add circulation fans, unless it's a natural barn, I'm not sure if this was a natural or a closed barn. If you only have circulation fans and no exhaust, then they're not going to perform very well. If it's a natural barn and you have good airflow, then I mean 3 and 12 slope is alluding to a natural barn. Ideally, it would be 4 and 12, right? But so if that's the case, then yeah, just start with the circulation fans. And if you see too much of a differences between summer and winter performance, then you could consider upgrading later to a retrofitting that natural into a tunnel using those circulation fans to help with the tunnel ventilation. So at least that's the way I would do it, but it will vary, I guess, on the specifics of how much we could do natural ventilation. If we can't, then we should do the exhaust first and then the cooling. But if we have the natural ventilation, then we can focus on the cooling.
Wonderful. Well, I don't see any more questions. And so we'll give everyone one more minute to type any last minute questions. But Dr. Mondaca, if you can go to the next slide. We just want to invite everyone for our next webinar, which will be with Hugh Jones with Royal de Boer. He's a ventilation specialist. And Monday, June 12th at 1 p.m. Central Time, he will be speaking on does ventilation pay back? So a really exciting topic that we know has a lot of interest and gets a lot of questions. I don't see any other questions coming in. So with that, thank you so much, Dr. Mondaca, for your wonderful presentation. And thank you everyone who took the hour out of their day to join us. We hope you have a good rest of the day. Thanks.
Thank you, everybody.